Okay, we're talking about 11.5, the B and C level problems. The first one I want to look at, this isn't a B level problem, I don't think. It's an A level problem, but it's a little bit tricky, so I thought I would put a video in of this one. Here's the problem. If 6 ounces of dough are needed to make an 8-inch pizza, how much dough will be needed to make a 16-inch pizza of the same thickness? And they give you a little hint. They tell you to compare the area of the pizza tops. So I got to figure out what the area of the 8-inch pizza is, and then I got to compare it to the area of the 16-inch pizza. So let's do that. The area of the 8-inch pizza has a radius of 4. Okay, right? Your pizza has a diameter of 8, and so the radius is 4. So we know the formula for the area, pi r squared, pi times 4 squared, 16 pi. 16 pi for the pizza area. And then the area for the 16-inch pizza is, well, the radius is 8 pi times 8 squared, which is 64 pi. Now, sometimes you would think that if you're comparing the area of an 8-inch pizza to the area of a 16-inch pizza, you're guessing it would be double. But look, folks, it's quadrupled. Now that's interesting. Okay, so the area of the 8-inch over the area of the 16, we needed 6 ounces for the 8-inch, and we need to know how many we need to find for the 16 inches. So remember, we said that this ratio here was 1 to 4. So 1 to 4 equals 6 to x. 1 to 4 equals 6 to x. And so we can see that x equals 24. 4 times 6 equals x, 24. So I need 24 ounces of dough. All right, so that is problem number 13. Problem number 18 is kind of an interesting problem. I like this one. Problem number 18 says, semicircles are constructed on the sides of the right triangle shown. If A equals 6 and B equals 8, show that the area of 1 plus the area of sector 2, or region 2, not sector, sorry, equals area of region 3. So here's my picture. This is region 1, region 2, and I have to show that if this area here plus this area here equals this area here. So I need to find the area of all three of them. All right, so the area of 1, this is a semicircle, so it's half the area of a big circle, so half pi r squared. Now, if this side length is 6, then the radius is, of course, going to be half of it, because 6 is the diameter. So 1/2 pi times 3 squared, so that's 9 pi over 2. Don't go ahead and divide that out, just leave it as 9 pi over 2. This next area, area 2 here, this is going to be half of an entire circle. This is a semicircle. If the radius or the diameter is 8, then the radius is going to be 4. So it's going to be 1/2 pi r squared, 1/2 pi times 4 squared. That is going to be 16 over 2, 8 pi units squared. So that's area 2. Now area 3, the radius is 5. The diameter is 10, the radius is 5. 1/2 pi r squared, that's going to be 25 pi over 2. All right? Now, we know that's what area 3 equals. What we have to show is that area 1 plus area 2 equals area 3. So area 1 was 9 pi over 2. Area 2 was 8 pi. So now we just have to add these fractions. 9 pi over 2 plus, well, I'm going to get a common denominator here. This is 16 pi over 2. Remember how to do this? 8 over 1 is equal to 16 over 2. Maybe I'll just show you this so that you can see that. Product of the means equals product of the extremes, so I did it right. Okay, 9 over 2 plus 16 over 2. The denominator stays the same. 9 plus 16 is 25 pi over 2, which just so happens to be what I figured out the region of area 3 was. So that's lovely. That's problem 18. And then the last problem here is problem 19. So let's look at this one now. This one's a little involved. If you just pop the answer out on this one, I'm going to know you didn't do the work. Okay, so again, this time instead of using numbers, they want to have variables. So this radius, or this diameter here is A, so you can see that the radius is A over 2. Remember when it was 6? It was 6 over 2, which was 3. Okay, the radius for B, the diameter is B, so this radius for this second area here, the second semicircle, is B over 2. And then this radius for this third semicircle is going to be C over 2. So we just have to grunt through the algebra here. Okay, the geometry part is easy. The area of this region 1, which is a semicircle, half of pi r squared. If r is A over 2, The only tricky part here, guys, is you got to make sure you can square a over 2. It's a squared over 2 squared. 2 squared is 4. Don't forget that, okay? The rule is ab squared equals, a over b squared is equal to a squared over b squared. So make sure you get that squared with each of the numerator and the denominator. Okay, so then what I have is a squared times pi in the numerator and 8 in the denominator. Okay, doing the same thing for area 2. 1/2 pi, and the radius here is b over 2. I have to square that, so I get b squared over 4, just like I had to do here. Oops. Just like I had to do there. Got to move that over. Okay, so 1/2 pi b squared over 4. All right, so I get b squared times pi over 8. So that's my area of 2. All right, my area for 3, the radius is c over 2 because the diameter is c. So 1/2 pi times c over 2 quantity squared. So that's c squared over 2 squared, c squared over 4 there. And then I have c squared times pi over 8. Okay, now what I have to do is I have to show that area 1 plus area 2, in fact, equals area 3. So area 1 I know is a squared pi over 8. Area 2 is b squared pi over 8. Now, what I can see is I can pull out a pi over 8. Okay, that's common to both of these things, using the reverse distributive property, right? Pull out the pi over 8, and what I'm left with is a squared plus b squared. Pi over 8 times a squared is a squared pi over 8, plus pi over 8 times b squared is b squared pi over 8. So you can see I did it right. But what do we know from the Pythagorean theorem? A squared plus b squared is equal to c squared from the Pythag theorem. So let me substitute into this equation a c squared. Pi over 8 times c squared. I just substituted right there. Well, lo and behold, area of 1 plus area of 2 equals area of 3. Whoopee. I don't know how to spell whoopee. I won't even try. I'll say whoop-de-doo. All right, I'm done. I should quit. I've been doing this too long.